Alright, particle motion. So I'm actually not going to go through all of the rules, but particle motion you should be able to do analytically, which means if I give you the functions, and that's going to be the example that I do today, or graphically. Remember, the key is, based off of what they give you, how do you get to the function that you want? So remember, if I give you S of t, but I want to do a v of t sine chart, then that means you're going to look at slopes. But if I give you v of t, and I want you to give me v of t sine chart, then you look at y values. If I give you v of t and I want a of t, then I would be looking at slopes again. That's the major thing about graphically. Outside of that, then everything else becomes the same. You should be able to tell me about moving forward, backwards, back, stopped, changing direction. I put these all together because we know to answer these questions you would have to use the velocity sine chart. You should be able to tell me displacement. This should already be in your notes. Displacement S of B minus S of A. You should be able to tell me the average velocity. That symbol looks like this, and that would be the displacement divided by time. You should be able to give me the average acceleration, which then becomes the velocities divided by time. You should be able to give me speeding up, slowing down. And you should be able to tell me about acceleration. So remember, speed, we want to talk about two functions, velocity and acceleration, unless you want to do it graphically, and that's probably the one difference. Graphically, speed, you want to look at if the graph of v of t goes away from the x-axis or towards the x-axis. And if it goes away from the x-axis, you're speeding up, and if you're going towards the x-axis, you're slowing down. So these are all notes that should already be in your foldable. So here's my question. It's an analytical question. So given that this is the position function, first let's start with, these are the three questions. Go ahead and press pause, and then check your answers. Alright, displacement, letter A. S sub B minus S sub A. And B will be S sub 2, and the A will be S sub 0. So S sub 2 will be 0, I believe, because you get, let's do that up here just to make sure, E squared times 4 minus 4, so yeah, that's 0. S sub 0 would be E to the 0, which is 1, times 0 minus 0, which is 0 again, so you get 0 minus 0. Average rate of change is 0. The displacement would be 0. When is the particle moving forward? So the fact that I'm asking when is the particle moving forward, I'm not asking you if the particle is moving forward at a specific time. I need a complete sine chart. So v of t is equal to leave the first one, derivative of the second, plus leave the second one, derivative of the first, that would be e to the u times the derivative of the inside, which would be 1. Factor out the common factor. That's the nice thing about e's. If it's a product, it will always factor out. So I get 2t minus 2. This is a plus, so plus t squared minus 2t. And if this was a minus, then I would have to have parentheses around this guy. I get e to the t times t squared minus 2. To do a sine chart, you want it equal to 0. E to the t never equals 0. T squared equals 2. T equals plus or minus root of 2. And then we also want to do where v of t equals undefined, but we don't have any places where e is undefined, and we don't have any places where the parabola is undefined, so that won't work or matter. So Sign chart starts at 0. So now we know I won't need negative. Alright. Now, some of you have a hard time with this. You could potentially do this. You could make the whole sign chart, and then you could chop off the piece that you don't need, which would be the negative values. If you do that, it does make your sign chart a little bit easier to understand. E of t is always positive. The graph of E of t looks like this. And there's an asymptote at the x-axis. So E of t is always positive, so I won't even have to worry about that when doing my sign chart. It's only this piece that I have to worry about. So if I put in 0, it's negative. If I put in a million and a negative 1 million or positive 1 million, I'll make these positive. So that's another way you could do your sign chart, and then chop off the piece that you don't need, and then start it at 0. So at 0, the velocity is actually negative, and it isn't until you hit root 2 that the velocity becomes 0, and the velocity is positive after. So the question was, when is the particle moving forward? It's moving forward. That's supposed to be enough. From root 2 to infinity for my times. The last question, speeding up or slowing down at time equal to 3. So speeding up or slowing down analytically, we look at two functions. So I would actually need to find the velocity at 3. Remember, we had that function a second ago. That was t squared minus 2. And then I would need to find A of t. So that'd be another product rule. E of t times 2t plus t squared minus 2 times e to the t, derivative of t is 1. Alright, so factor out again. Common factor, 2t plus t squared minus 2. And what's nice about me asking you for speeding up at 3, you don't need a sign chart. I'm only asking you at 3. So if I put 3 into here, I don't care about the value. E to the third is positive. 3 squared is 9. 9 minus 2 is positive, so this is positive. So this again, this piece here is always positive. This is 6 plus 9 minus 2, which is also positive. So E of 3 and A of 3, both positive. Therefore, speeding up. Now, if I asked you to find where the particle speeds up, you would actually have to do a sign chart for acceleration. So we'd have to go through finishing this problem.